welcome to the first video of our topic, linear motion and forces. In this video we're going to talk through describing motion, and we're also going to talk about velocity, the two different types of velocity that we're going to discuss, and some equations. Well, one to start with, and when we start to move on to other stuff, we'll introduce more and more equations. So the first thing we're going to do is talk about describing motion. Now, all objects that are moving, so one point we can talk about is moving. We could say any object that's moving, it can be described as moving slow or fast. It could be accelerating, or slowing down. And throughout this entire topic, we're going to start to look at how we can mathematically describe the motion of an object. So let's start by talking about velocity. So when we're talking about velocity, we're going to talk about two different types. The first type we're going to talk about is average velocity. So what is average velocity? Well, what average velocity is the average velocity, which is also known as speed, but velocity generally has or should have a direction. So speed is how fast something is traveling, velocity is how fast something is traveling with a direction. So I'll write that up in a moment and get you guys to also think about that. So to simplify it, really simplify it, we're going to talk about the average speed it takes to get from point A to point B in a given time frame. So we could say that average velocity is the average speed in which an object moves from point A to point B in a given time. And we have a formula which we can use for this. So let's move that up a bit. So the formula that we're going to use for this is V subscript AV. So the AV there is average, is going to be equal to the displacement over time. Now, displacement, you're probably more familiar with it as distance, but when we're talking about displacement, what we're talking about is straight line distance from a reference position. So I'll put that down here. And we use the symbol S for it. So what do we mean by a reference position? Well, we take any position which we start as being displacement of 0. So it could be simple as getting up from your chair and moving to the bin. So your reference position is your chair. If you go up from your chair, move to the bin, you've moved that distance. But when you come back and sit back down, your total displacement is actually 0. So you've moved up, you've moved to the bin, and you've moved back, but your displacement from where you started is 0. The actual distance that you've moved is from the chair to the bin and back. So it's a little bit different to distance, but we'll talk about it a little bit more in class and clarify it a little bit as well. So you're probably familiar with this formula as being velocity equals distance over time. It's the exact same formula, we're just changing some of the words. Now, what are the standard international units, or SI units, of each of these? Well, for velocity, and it doesn't matter whether we're talking about average velocity or instantaneous velocity, which we're going to touch on in a moment, it's meters per second. For displacement, S, it's meters. And for time, T, it's seconds. So meters per second, or meters divided by seconds, that's what meters per second stands for, is displacement divided by time. So that's where meters per second comes from. So the next thing I want to touch on is instantaneous velocity. However, before we get to that, let's do a quick little example of this, well, using this formula here. So let's scroll up a little bit, and I'm going to rewrite this formula in its short form. So VAV is equal to S over T. Alright, so let's look at an example. If we've got a person who can complete a 100-meter race, and it takes them 20 seconds, what is their average velocity? So the way I want you guys to set this out, and I'm just going to move this over a little bit, is going to be S is going to be equal to that, T is going to be equal to that, and VAV. I just put a question mark there because that's what I want to find out. So setting it out like this, you can clearly see what facts you are using. Alright, so we've got the facts. Let's just write that next to it. Now we need the formula, which is up here. And now we need to find the answer. So we're going to facts, formula, find it, fix it. So when we're doing find it, we're going to plug in the values we've got into our formula. So in this case, I'm going to go VAV is going to be equal to 100 divided by 20. Now, if we go through and work this out, VAV is going to be equal to 100 divided by 20 is going to give us 5 meters per second. So what we've got here is our find it, and here is fix it. Alright, it's 5 meters per second. That's pretty quick, so you're covering 5 meters every second. Okay, not everything's going to be in meters and seconds. Generally, if I look at an example of that we're driving a car, cars we measure the velocity in kilometers per hour. So we need a way to convert kilometers per hour into meters per second. So there is a really simple way to do this, and I'm just going to scroll right up. So we've got kilometers per hour, and I'm going to be consistent here. So km hr to the power of -1 is the same as kilometers per hour. So this here is just divide. And then we want to go to meters per second. Now, to go from kilometers per hour to meters per second, what we need to do is divide by 3.6. And if we want to go from meters per second to kilometers per hour, we multiply by 3.6. Now, why 3.6? Well, we've got, let's do a quick bit of calculation here, and I'm going to pick green to do it in. So, if we've got kilometers per hour, so how many seconds are in an hour? So, we've got 60 seconds in a minute, multiplied by 60 minutes in an hour. That gives us 3,600. How many? So let's go. Whoops. Per hour. And meters per kilometer is 1,000. So 3,600 divided by 1,000 gives us that lovely 3.6. And it works both ways. So we use it to divide whatever in kilometers per hour into meters per second, or we multiply by 3.6 to get kilometers per hour. Okay, so let's look at another example. If we're going from, well, let's actually work out a little bit differently here. Let's do another example where, let's scroll up. Let's write out our formula first. VAV is equal to S over T. Okay, if we've got the Concorde flying. Now, the Concorde was a supersonic passenger jet that flew back in the 90s and early 2000s before it was retired. It has an average velocity, so VAV, of 1,440 kilometers per hour. And it flies in, we're going to time it for 1 minute. And how far has it flown in that time? So the first thing I'm going to do is convert the kilometers per hour and minutes into our standard SI units. So I'm going to go 1,440 divided by 3.6 equals, and I'm going straight to the calculator for this, 1,440 divided by 3.6 is 400 meters per second. It's pretty quick. And 1 minute is 60 seconds. Okay, now we're going to just rearrange this formula here to find what S is. And S is just going to be equal to VAV multiplied by the time. Alright, so now we've got our facts, we've got our formula, we've rearranged it, let's find it. So I'm going to go S is going to be equal to 400 multiplied by 60. So S is going to be equal to 24,000 meters. And if we want to make it a little bit easier, we could say that it's 24 kilometers, which is pretty quick. So that's what we need to do. And whenever you're working on equations like this, do not forget your units. So that's just 2 examples. We'll go through more in class if we need to. All right, the next thing I want to talk about is our instantaneous velocity. Now, I touched on this earlier. So what is velocity? So instantaneous velocity is the velocity that we are traveling, or that an object, should I say, traveling at a particular moment in time. So an example of this is the speedo in a car or a motorbike or on any kind of vehicle. It tells you what your instantaneous velocity is. So your average velocity will tell you how long your average speed to get from point A to point B. Your instantaneous velocity is how fast you are traveling at that particular moment in time. So there's no real formula for this one at the moment. We'll go through some later on. So that's all I really want to go through in this video. In the next video, we're going to go through acceleration and what that is. We're going to define it and look at some formulas for it. And then we're going to look at some motion graphs in a later video as well. So we'll do all the motion graphs together. Alright, thanks for watching. If you've got any feedback on this video, please let me know. I'm open to any suggestions that you might have. Thanks for watching, and if you've got any questions, just ask. We'll see you next time.